Hi, welcome to another lecture of JS Yatra, and in this particular video we are going to solve the question HTML serializer. The level of this question is hard, so without wasting any time, let's get started. This particular question you will be given a data which is something like a tree containing an object, and inside you have a tag and the children. So tag is a very basic tag like div tags, span tag, body tag, or whatsoever, and followed by that children would be an array in which again you will have an array of objects where this object is particularly following the same pattern of the parent, which is tag and children. So here you can see that here the body is having two children, children 1 and children 2. The children 1 is having a tag div. So this particular div tag is having one children, which is p tag, and this p tag is having two children, which is simple text, text1 and text2. The next sibling of the div tag is a span tag, which is containing only a text as a children, which is text3. So our task is to serialize this data and generate a output which is something like this. So here you can see that we got a body tag, we got a div tag inside it, and then we have got a p tag. P tag is having text1 and text2. Then we close the p tag, then we close the div tag, then we open a span tag, and we inside the span tag we add text3 and we close the span tag. And we have to take care of the indentation as well. So indentation is slightly broken. Let me fix that. All right, I think this looks good. Yeah, so we have to take care of indentation as well. What we mean by that is body should have 0 indentation from the left, and the div tag should have one tab space. Then its children should have two tab space, then 3 tab space, then again 3 tab space, then 2, then 1, then again 1, then 2, 1 and 0. So we have to take care of the indentation. Also we have to make sure that these characters put up on a new line every time. So that is our task. So the task is very simple, that given this data structure we have to serialize this data and generate this type of output. So let's dive into the solution. All right, so to solve this question, first let us have a clear look at the data provided. The format is like tag and children, tag and children, tag and children. So you can see a definite pattern in this particular data which we have been provided to us. So if there is a particular repetition in the data, the first approach that comes in the mind is recursion. Okay, this is the best question to implement the recursion, and let us see how we are going to achieve it. And one thing more, that if you are still confused like how we are going to achieve the indentation and the new line, so I can help you on this part. So on this part body div and other stuffs, so let me just fix this for you. So for new line, there is a /n character, and followed to add one tab, there is /t. Okay, so /t is for tab, /n is for new line. And again, there were two tab spaces and there was one line break. So this would become /n/t/t and so on. So this is what we are targeting to generate. Okay, it is impossible to generate a tag like this without the use of new line and the tab spaces. So we are heavily going to use this, and we'll see how it is going to fit in the solution that we are going to implement. But to give you a small idea, this is what we'll be targeting in the solution. So let us take up the code, and inside the code we'll be taking up the node. This is the node that we have received. And first of all, I'll create some variables for us. Const indent would be a /t. Const new line would be a /n. We got these two. Now let's create a function over here that would take up most of the logics, and we will also create one util function that will add tab spaces based on the number of repetitions. So In the first line, you can see that we have 0 tab spaces. In the second line, we have 1. In the third line, we have 2, and so on. So we will create a function const add tabs, and we'll call it as repeat by, and we'll do indent dot repeat by. Okay, this is one new thing. Dot repeat, if you are not familiar, dot repeat is string JavaScript. So repeat method constructs and returns a new string which contains the specified number of copies of the string on which it was called. So here you can see that if we write, there is a const mood which is containing happy, and if I write I feel mood.repeat 3, then it repeats this mood variable which contains happy 3 times. So I feel happy is what is being rendered. And this is exactly fitting our use case, because we also want to repeat the indentations based on the number of iterations. Okay, how many times you want to repeat this character. So I passed a variable, and this would generate like n number of repeated tabs for us. All right, so this was like the indentation, the new line, the add tabs. This was the data for us. This is the expected output. This is the place where we are calling the serialize tree function, and here we are writing our code. So first we'll create, since it is a recursive method, so what I'll suggest is we first of all create a function that would be called recursively. It would be something like const traverse tree. Okay, this is our traverse tree function, and we are going to call this thing over here, and obviously we are going to return. So return the traverse tree, and this traverse tree is taking up the node, and traverse tree will take up the node, and we also want to maintain the depth as well after each recursive call. By what I mean by depth is that here you notice that on the first, when the depth is 0, then there are no tabs. When the depth is 1, there is 1 tab. When the depth is 2, there are 2 tabs. Okay, this is what the basic depth meaning of depth is. So initially, when this function would be called, the depth would be 0. Okay, there is ideally no depth. And first thing first is that if node dot children, so if there is since this is a recursion, so let us first write the base conditions. The base condition is that very easy, that you can see that these leaf nodes are not containing any children. For example, this text1 node is just a plain text, and it is not containing any children. So this text1 is our base condition. So when our recursive call lands on text1, this text1 is not containing any children, so we will return text1 as it is. So if not node dot children, then return node. Okay, this is what we have to return. If there is node, if there are children in the nodes, then what we have to do is we have to return an array. Why an array? That is something I'll tell you later, but let us try to fill the gaps. Okay, what I mean by gap is for example, if you take up this part, okay, regarding the p tag. So p tag, there was a /n /t and followed by a text1, then again a new line, then followed by /t, then followed by text2, then followed by /n /t, and we close the p tag and followed by /n. Okay, so if we take this particular example of p tag, let me fix this. I guess we have some error over here. So p tag is receiving 2 indents, so text1 would receive 3 indents and text2 as well, and then we'll close p with 2 indents, and yeah, this is now fixed. So let us take this particular p tag over here. Let me copy this and paste it over here, you can see that this is an array as well. How is this an array? It is really very simple. Let me put this inside brackets, very easy, and I separate it from slash ends like this. And over here you can see, yep. So have a look at this. So this is what I was talking about. You can see that there are 4 elements in this array. This is having 2 indents, this is having 3 indents. Okay, don't get confused. It is having 3 indents, it is having 3 indents and a text2 followed by slash n slash n slash n, and there is a 2 indent, and we close the p tag. If I remove the slash n from here and I do dot join, this is again the same thing, right? And all we have to do care about now is this is having the tag. This is tree dot tag. Okay, tree dot tag, then children, then again we close up with tree dot tag. Okay, try to see the pattern over here. In the first element is tree dot tag. For example, the tag is p, then there are children, so there comes the children, then we again close it with 3 dot tag. Although there is we have prefix of indentations which will be handled by add tabs function over here. So it is add tabs 2, add tabs 3, add tabs 3, add tabs 2, then this is tree dot tag, tree dot children, tree dot children, tree dot tag, then followed by join with new line. Okay, this is the pattern that I wanted you to see. So we'll stick to this particular pattern in this question as well. So the first item here would be tree dot tag. So we'll have something like this, and tree dot tag is actually node, so node dot tag, and we'll have opening brackets, then there will be some room for the children, and then there will be some closing tags again. So we will close it like this with a slash, and before each tag we are having n number of tabs as well. So we will call this add tabs functions over here like this, and I will add tabs, and I will pass the depth over here like this, and let's call it again over here as well, and unexpected comma middle of the array because we have not filled the children. So now we have the opening tag, we have got the closing tag, and what I am missing here is join. So we will call a join over here, and this would be a new line. So we are joining it with the new line, and we are missing children. Children is an array item as well over here. So there are 2 children item, text1 and text2. So we are having again, so here would be 2 array items for text1 and text2. At total we will be having 4 items being returned. But children is something which is dynamic. One tag can have 10, one tag can have 5, another can have 6, and so on. So we are not sure how many children are there inside a particular parent or a particular node. So to do that, one data structure we need is something where we can traverse each children item, and that item returns us the computed array. Think of something which comes to the mind, which can iterate over the array items, and it performs a certain callback over that array item and gives us the gives us that particular thing. How shall we do that? So the data structure, the utility method coming to your mind might be the array.map. You're absolutely correct, but we need to also flatten the array by to the 1 level. Why do we need to flatten? Is because at the end we are performing a join method. Okay, we can't have multi-level array nested being returned over here. So it is a need for us to, whatever is being returned from the serialized tree function is an array of what, array containing items that are being nested onto a single level only. We don't want multi-level nesting. So to fix that, it is really very simple. Instead of map, you will be using flat maps. And if you are not aware of flat map, then let me take you. Flat map method returns a new array found by applying a given callback function to each elements of the array, and then flattening the result by one level. So whatsoever be the nesting level, you have the flat map flattens that result by one level only. So this is a really very great thing, and we'll be using exactly the same. So dot 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 it is node dot children dot flat map. We get a child, and again I am calling the traverse tree function recursively on the child. Let me fix this and let me clear this out. Alright, so I think this was the solution. Let us try to console log. Alright, so obviously in this particular thing we are not able to see it. Okay, and why is that? Okay, let us stringify it. JSON dot stringify. Yep, and now we can see it. All right, so you can see body, then again a new line, body, again a new line div. All right, so we are not able to see the proper indentations. And yeah, I guess why is that so? Because we haven't utilized the depth. So we have to increment the depth by one when we are recursively calling the function again. So now you can see that we have got a body. Let us have it over here, body, then /n/t div. Then there is again some children, so /n/t/tp. Then again we have /n of text1 /n of text2 /n/n text_t. And why we are not getting on the children? Okay, so we are not getting the tabs on the children because we forgot to add tabs over here. Obviously, because when we are returning the text, when we are returning the leaf items which is being returned from this base condition, we have to take care of the depth and add the necessary number of tabs over here. So that was a miss, but again we can fix this. It is really very easy. Yes, now you can see that we got /t/tp /n/t/t/t 3 times, text1 and text2 following the same pattern, then 2 times p, then /n/t div /nt span text3 span /n and body. This is exactly what we needed, and yeah, this was the HTML serialize solution for you. The level of this question was hard, as you can have seen the the way we have approached this question, and it required a lot of understanding of the recursion. It is a good recursion question as well, and it is being asked many of the times in the interviews, and sometimes it gets really tricky if you haven't solved this question before. So yeah, this was all in this particular lecture, and I hope you liked it. If you have any doubts, then please ask me in the community or in the Discord channel, and see you in the next one.